and we'll get started on what we're going to do today. So today we're going to learn how to add and subtract matrices. We're also going to learn how to multiply by a scalar, and we will be able to perform operations with matrices related to real-world problems. So just like always, main goal, getting you guys to understand this in a real-world scenario. I will tell you right now that the notes are pretty simple. The only thing that's really different from just adding and subtracting numbers is the fact that we have a fancy schmancy matrix, and that's pretty much all that's different. So you guys should do pretty well. If you have questions as we go along, let me know. So this first one that we have up here, I have a matrix A, which equals 6, -7, 2, and -12. And I have a matrix B that equals 4, 2, -5, and -6. I want to find A plus B. So the way that we're going to do this, kind of talked about it in the video that we watched on Friday, but all you do is you just match up your elements. So upper right hand or upper left hand goes with upper left hand, upper right hand goes with upper right hand, so on and so forth. And we'll just go ahead and go through this. So that means A plus B, 6 plus 4 is 10, -7 plus 2 is -5, 2 plus -5 is -3, and -12 plus -6 is -18. So like I said, not a bunch of math, like deep math going on here. Only thing that's really changing is that we've put it in these brackets and we're just adding these numbers that way. The biggest thing you're going to want to pay attention to is the order of your numbers and make sure that you are adding the correct parts. So just like if I had a matrix and I flipped it, so I had a 3 by 2 and I changed it to a 2 by 3, we always make sure that my elements are in the same place. Same idea here. Make sure you're adding the elements that are in the same place. Another thing that you need to notice about adding matrices is that we cannot add matrices if they have a different dimension. So just like the video talked about, if I tried to do something that had a different dimension, I had maybe just a column matrix, if B was just a column matrix, I wouldn't have anything to add my second column of A to. So I couldn't add those together. They need to have the same dimensions. So that's what this one is for. Even though I have the same number of elements in those two matrices, they are not the same dimension. I have a column matrix versus a row matrix. I can't just put those together. They don't just create a new matrix. It would be like taking, like we talked about, a column of you guys and a row of you guys and trying to put you guys together and make you look the same. It's not going to work because we have a column and a row. Can't put them together. All right. So now we want to find A minus B. So in this case, A equals -2, 8, 3, and -4, 10, and 7. B equals 4, -3, -2, 1, -6, and 8. So if you can't see it, that's what those are. Does anyone think that subtracting matrices will be different from adding matrices? What do you think will be different?
I'll probably just change the sign on there.
So all we're doing is changing the sign. And that's essentially what's happening, is we're doing the same exact thing, but we're just changing the sign. So instead of adding it, we're going to subtract. So same idea. We're going to get a matrix. -2 minus 4 is -6. 8 minus -3. 3 minus -2. -4 minus 1. 10 minus -6, and 7 minus 8. Once again, not really difficult to add and subtract numbers. The only thing that's different than you guys doing this in elementary school is that we have matrices. So that's pretty much the only difference in this, so it should be pretty simple. I think there's one more on here. Okay, so number 6. I want you guys to do this one on your own. So I'll give you guys some time to work on that. I'll give you about 2-ish minutes. Alright, so I think most of us are finished, and the ones who aren't, I think you're just putting it into your calculator. So that's okay. Thank you for working during that whole time. I think I saw Grant Lackey. Did you have this one done? Did you finish it? Okay. Do you want to tell me what you got? Okay. Does anyone disagree with what Grant has? Are we good? Okay. Yeah. So like I said, pretty simple. Only difference in this one is that I had you guys do fractions. I know fractions aren't the best thing, but it's good that we understand fractions. If you want to change it to a decimal, you can always do that too. Does anyone have any questions on adding and subtracting matrices? Okay. Pretty simple. That was not what I wanted to do. Okay. Let's just ignore that. All right. There we go. Sorry. I don't know what happened. All right. So now we're going to do this thing called multiplying by a scalar. Does anyone happen to know what a scalar is or has heard the word before? You don't have to necessarily know what it is, but if you've heard the word before. Yeah, so a scalar, written like this, S-C-A-L-A-R, it's just a constant. So it's just a number that you're going to multiply. So one of the places that matrices are used a lot is in physics to solve systems of equations and things like that. And in physics, you use a term called scalar. Sciences, you use a lot of that. So in this case, we're going to use scalar. All it means is a constant, just a fancy name for a number, because physicists and mathematicians like to make it difficult on us. So what we have here is we have three matrices. So I have matrix A, matrix B, and matrix C. So I have these up here because now what I can do is I could just write something on this board and say I want you to do this with A and B, and then you just have those right there and we don't have to worry about writing those matrices over and over again. So if I want to multiply by a scalar, let's say I want to go 4 times A, you might get a problem that looks like this. All that means is you take your constant 4 and you're going to multiply it by your matrix A. So just like when you substitute variables in, if you have like C equals something, you substitute it into an equation, same idea. In this case, my variable is A, or my matrix is A, so I'll just do 4 times 3, 4, 2, 3. And then, just like when you pull a number out of some parentheses, you can FOIL that. So same idea, just FOIL that 4 all the way across. And now you keep your numbers in the same place. So upper left-hand corner would be 4 times 3, which is 12. Upper right-hand, 4 times 2, which is 8. 4 times 4 is 16. 4 times 3 is 12. Pretty simple. Questions on that? Okay. So you might not get a problem that just asks you to do one step. You might get a problem that asks you to do something like this. So I want you guys to go ahead and on the sheet of paper that you got out to do the problem before, I want you to go ahead and do that one. You can do it on your own. You can talk to other people. It's fine. Whatever you want to do, but just make sure you're working on that. Okay. Does anyone disagree with that before I continue? Okay. So those are pretty simple because all you're doing is just doing that multiplication and then adding them together. And so those, just having the straight math, you guys should be good with that. Does anyone have any questions before I move on to another one? Okay. So here's what we're going to do now is I think we have accomplished doing adding and subtracting matrices and multiplying by a scalar. So now we want to work with the word problems. So this one says matrix H is a 3x1 matrix that contains the initial heights of 3 sunflowers. Matrix G is a 3x1 matrix that contains the number of inches that corresponding sunflowers grow in a week. What does matrix H plus 4G represent? So I want you to turn to your elbow buddy, and if you don't have an elbow buddy, you can turn around, find someone that you can group up with. And I want you guys to share what you think matrix H plus 4G represents. So I hear everybody talking. So matrix H is the initial height, and matrix G is the inches that it grows in a week. All right, so let's bring it back. Brennan, what? I heard your group talking. What did your group say this was?
It was the height of the sunflower after 4 weeks.
The height of the sunflowers after 4 weeks. So we're talking about matrix H starting there. And after 4 weeks, we can see how much it's grown, add those two numbers together, and we will get how tall our sunflowers are after 4 weeks. Unless you guys are gardeners, I don't really think that this will help you out a whole lot, but I thought this was kind of a fun problem to talk about. We're going to do one more problem. Still doing word problems. So I have a table up here that shows the prices for dishes at a restaurant. So I have lamb, chicken, and steak. I have regular portions, and I have half portions. On your sheet of paper, I want you guys to write down a matrix that represents this information. All right, I'm going to call the matrix M, just because I'm just picking a random letter. Sarah, what does your matrix look like?
Okay, it's 3 by 2.
3 by 2?
And it's 17, 14, 22, and then 9, 7, 11.
Awesome. Does anybody's matrix look different than Sarah's? Could I have done a 2 by 3? So it doesn't matter what it looks like as long as I have all my numbers in the correct place. I can't go 17 and then 7, 14 and then 9 and 22 and 11. That's not going to work because that doesn't help me. It doesn't look like my table. All right, now here's what I want you to do. I want you guys to write an expression. And this expression will represent the cost of this meal, the cost of one of these things, or the cost of the matrix, including 20% tax and tip. So think about what we've done, adding our matrices, multiplying by a scalar, and I want you to think about writing an expression that will include 20% tax and tip. You guys can go ahead and work on this together with your elbow buddy or with your group. Figure out what that expression would be, and your variable that you're going to use is M because your matrix is M. So use this as your variable as you try to figure this one out.
Took the matrix and times or multiplied it by 0.2, and then I added the same matrix, so I could have just multiplied it by 1.2, I guess.
Yeah. So and that's fine because that could be the first step. So thinking about how 20% as a decimal, that's 0.2. We know I want to figure out how much 20% of this matrix is, so I would be doing 0.2 times M. But that's not just what I want because I want to know what the total cost is. So I want to know how much 20% of it is, and then add on top of that the original cost. So adding M. which is a good first step. And then, like Brady was saying, you could just simplify that out to, say, 1.2m. Does that make sense? So figuring out an expression like that could help you. I mean, if you have a whole group of people going out to eat, you could figure out how much it's going to cost for all of you guys to eat with a tax and tip without having to go piece by piece. I want you guys now to compute or figure out what 1.2 times m is. Or 0.2 times m plus m, whichever one you want to do. Alright, so Hillary or Caitlin, whichever one you guys want to go, do you want to tell me what you got for your answer? Don't be afraid.
I'll go. 20.4. And then to the side, 10.8. 16.8.
If you're talking, make sure you stop talking because we are working on this now, and I want you to give Caitlin the same respect that she gives you guys when you guys are answering questions that I ask you. Alright, continue.
8.4. 26.4. And 13.2.
Alright, so what did I just find? Doing 1.2 times m tells me what? In real words? In, like, not mathematical terms? The price with tax and tip. So if we're talking about that, it's also good to think about what this real-world application is, because now we can go back through and say I'm talking about $20.40, 80 cents, so on and so forth. So not that your answer was incorrect, just adding that zero on. So if you gave me this and you said this is how much it'll cost, I can just look at that and say, okay, I have $20.40, $10.80, etc., etc. Looking back at this matrix, so this is 1.2 times m. We'll just point that way. Looking back at this m matrix, before we include tax and tip, what is the price difference for lamb between the regular portion and the half portion? So let's look at our matrix M. Which row represents lamb? The first, second, or third row? The first. First column is regular, second column is half. So it's the price difference between a regular and a half portion. 8. There we go. So our price difference here would be 8. What about for our next one? 7. And the last one? 11. Questions? Okay, I forgot one thing that I want to tell you guys before you start your homework. Because there are some problems on here that just like when you started multiplying numbers and variables, you had to learn some properties. So I want to put these on here because I forgot to put them on here. So these properties hold true for matrices. And I forgot to put that on there, but I want you guys to know that those are properties that hold true. So I can add my matrices. I could add A and B, and it would be the same thing as adding B and A. As you get into higher math, that might not always hold true, so it's important to know for this. Also, you can separate A and B. You could add those separately, and then add C to it, and you would get the same thing as adding B and C separately, and then adding C to it. And then down here, K just stands for our scalar. So if I have A plus B, I could add those first and then multiply that all by a scalar. Or I could do it like some of you guys were probably doing it when we worked on this, where you multiplied by the scalar, and then you multiplied by another scalar, and you added those together. And then you could just swap it, so add and then do that. So does anyone have any questions before I let you guys work on your homework? Okay. Before